Hi, this is Tom Delaney, and this is a brief screencast where we're going to go over some logistic regression procedures in SPSS, and even more specifically, bivariate logistic regression. What we have here is an example data set that has 4 variables. The first variable is unique ID, and that's just an identifying number. It won't wind up in any of the actual logistic regressions, but we can use it. For example, if we have to delete cases, it'll help us know which cases to delete. The next variable is called MJ days, and this is, again, in this made-up data set, it's marijuana days, and that means self-reported days out of the past 30 days that someone says they used marijuana at least once. So this number ranges from like 1 all the way up to 30, and in this data set, it's only among marijuana users, so there's no zeros. The next variable we have is gender, and it's coded specifically as gender female. So 0 is not female, and 1 is female. We're actually only using 2 categories of gender, but if we had a much larger data set, we'd probably include other categories as well. And the last variable is our outcome variable, and it's called elevated absent days. So in this example data set, everybody was split into either having relatively more days, maybe over the median absent days in the past 30, or fewer than the median days absent in the past 30. And what we're going to examine is whether marijuana days, which is a continuous predictor variable, and gender female, which is a dichotomous and so categorical predictor variable, are associated with changes in having more versus fewer days of absence. Let's go ahead and run this thing. I'm going to start by going to Analyze, Regression, Bivariate Logistic. Now there's different ways you can set up bivariate logistic regressions. I'm going to show you a very basic way, but you may have other reasons, for example, from taking Epidemiology 2 or tutorials on the internet, where you make some different decisions. But these are sort of basic, pretty common decisions that you would make. So let's start by identifying the dependent measure, and that's days absent, which is again a categorical dichotomous variable, which it has to be in logistic. You have to have a 2-level variable, and it's also preferable in logistic if the variables are coded 0 and 1 for dependence. And then we'll go ahead and we'll stick the female yes/no variable as a covariate, and days used in the past 30 days as a continuous covariate. Now we do have to, for any categorical predictor variable, we have to go up here to the categorical box, click on that, and just pull over the variables that are categorical. And this is going to let SPSS know that it has to treat those variables differently than it would a continuous predictor variable. The reference category is whether the event, in this case whether or not the person is coded as female, is the first category or last category. I think it's going to be simpler in this example if we actually keep it as last, which is the default here. So we'll keep that last. You could actually switch it so the first category is the reference category. Let's hit continue. And 1 or 2 remaining decisions before we actually run the logistic regression. So one is that we have to choose the method, and the default is usually enter, and that's actually what we want to use. But there are other conditions where you can, for example, set conditional logistic regression where it uses a rule to decide whether or not to include variables. But we're not going to do that. So if it's not set to enter for you, you might want to consider setting it to enter. That's sort of the classic logistic approach. And then let's go up to options. For options, there's a few things. We won't go into detail about classification plots, but that's a good thing to request. Hosmer-Lemishow test is also good to request. This is a goodness of fits test that can tell us whether the overall model is relatively good at explaining change in the outcome variable versus relatively not so good. Let's request that. Residuals is something we won't examine in the screencast, but it can actually be helpful to examine patterns of residuals, so let's request that. And the last thing we're going to request here is the confidence intervals. So the EXPB is the exponentiated beta weights And these are what's actually interpreted as the odds ratios. And odds ratios are what we like to interpret for bivariate logistic regression. And it's always good to have that 95% confidence intervals when we're interpreting an estimate like that. So we'll go ahead and request the CI for the EXPBs. And all this other stuff looks pretty good. We can actually request the display at the last step. We don't need every single step of the equation to show us the statistics and plots. We can leave the entry and removal points as they are. Continue. We don't have a selection variable. We can ignore that. So let's go ahead and run it. All right, let's go through the output just a little bit. Up here is the syntax of what was actually requested. That can be helpful to keep, so you can refer back and see what you did later on. Here's the case processing summary. So 60 is the correct number of cases. Here's the dependent variable coding, and this is correct. This is my understanding of the coding. 0 is fewer days absent, 1 is more days absent. And categorical variable coding, we're going to skip that for the moment. Variables in the equation, variables not in the equation. And then here's the method equals enter again. And let's go down and actually take a peek at this. So the model summary is a way of quantifying the total amount of variability of change in the outcome variable as a function of the set of predictor variables that you have in your logistic regression equation. So this is kind of like an R-square. It's like proportion of variance explained, except it's not a real R-square. It's called a pseudo R-square or fake R-square. In this case, we have two different estimates that were given. The Cox and Snell R-square is a little bit lower than the other one, but that's actually reasonable. That's saying that we're accounting for 26.4% of the total variability in the change of the outcome as a function of those two predictors. And Nagelkirche, if I'm saying that right, is an even higher estimate. And these are just good things to know, and you'll see that as you add and remove variables from logistic regression equations, you'll see that these will fluctuate, and you can use these as sort of a marker to inform how good your model is. The Hosmer-Lemeshow test, this is one where when you have an obtained p-value of less than 0.05, it implies problems with goodness of fit. We have a significant less than 0.05 statistic for Hosmer-Lemeshow, so in a real-world logistic regression, we'd probably want to examine that and think about why we might have that, and it might imply that we need to change our variables. And let's go down to the final thing, the big payoff here. So this table, variables in the equation, includes the outcomes and the output for the two predictors. So for the categorical predictor of female, not female, we have the beta weights, standard error beta weights. Then we have the Wald statistic, which is kind of like a chi-square statistic. If we go over here, we have the EXPBs, the exponentiated beta weights. And you can see, we know that with these, that 1 is the default. And so having 1.025 as basically an odds ratio is a really small change. And that says to me that there's actually very little impact on the outcome variable as a function of whether the case was coded as a male versus not female. And then we also have the 95% confidence interval here, and you can see that includes 1, so it implies that it's not a significant odds ratio. However, let's go down to the other variable, the continuous predictor variable of days used out of the past 30. Beta weight looks different. This is a big value for 8.9 is a big value for Wald. Significance is 0.003, so it's pretty significant. And then here's the odds ratio. So this odds ratio implies that if you're, let's see if we can interpret this correctly. People who are more likely to use are at an elevated likelihood of missing days, of being classified into that higher or elevated days absent variable than are people who are using marijuana on fewer days. And another way we know this is significant is because the 95% confidence interval does not include 1. The range of the estimates is from 1.07 to 1.38. So these are really the things that we would wind up actually interpreting and probably reporting in a results section. But we definitely have to keep track of all these other things too. And because we do have this Hosmer-Lemeshow significant finding, we would probably have to go back and examine our logistic regression and think about why it might be working better or not working so well. And that would be a topic for another screencast. Have a good day.